All right, 5.2 Intro to SSS and SAS triangles. So to start off, we're going to talk about the reflexive property when dealing with sides and angles. It says a side shared by two triangles. So in this case, if you look here, we have two triangles. This side right here is being shared by the two triangles, the one on top and the one on bottom. And so if a side is shared by two triangles, it is congruent to itself. And so we can say that side CR is congruent to side CR because they are the exact same. And so the reflexive property would say that because this is the same side shared, it's congruent to itself. Then you can also have an angle shared by two triangles. So if you look here, we have this triangle, ABC, and then you have triangle DEC. Both of these triangles share angle C. And so you can see here an angle shared by two triangles because it's congruent to itself. So we can say that angle C is congruent to angle C. We're going to use this property when we're proving triangles using these different theorems. So if all corresponding angles and sides of two triangles are congruent, which is what we talked about in 5.1, then the triangles are congruent. However, you can prove triangles using fewer parts. So in 5.1, this is kind of what we talked about here, okay? Is the fact that in the 5.1 notes, we talked about if two triangles are congruent, then every corresponding angle and side are also congruent. But sometimes you're not going to be given that information. And so you're going to have to use fewer parts. So the first one that we are going to be using is side, 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 also known as SSS. It says, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So if you look here, we have two different triangles. The first side that we have is side AB. So it says if AB is congruent, and in this case, we know it's congruent to DE because they both have one tick mark. So these two sides are congruent to each other. Then if I'm looking at the rest of the triangle, I can see that these two sides are congruent to each other. So side BC is congruent to side EF, also considered a side. And then you can see that because these have three tick marks, those are congruent. So side AC is congruent to side DF. So if we have three sides, 1, 2, 3, that are congruent to another triangle, then we can say that triangle ABC is congruent to triangle. Now, when you do this congruency statement, you have to make sure that your order is in the correct order. And so if I went with triangle ABC, A is congruent to D, so I have to start off with D. B is congruent to E, and then C is congruent to F. So you have to make sure that your congruency statement is in the correct order. Okay, so this is how you're going to be identifying by side, 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 is that if there are three congruent sides for each triangle. So let's look at here. We're going to state whether the triangles could be proven congruent, if possible, by side, side, side. Well, in example 1, I can see here that this side of this triangle is congruent to this side of this triangle. And so because I know I'm going to be dealing with side, 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 I would say side AD is congruent to BC because both of those are marked with one tick mark. Then I know that these two are congruent. And so for this triangle, I would say, this is referring to sides, that DC is congruent to BA. Okay, so those two are congruent there. Now, this side, if you notice, is not marked to be congruent. However, applying the reflexive property from here, where it says a side shared by two triangles is congruent to itself, well, in this case, this side is shared by both of these triangles. And so we know by the reflexive property that AC is congruent to AC. It's congruent to itself. So we can mark this as with 3 tick marks to show that that is the third side of each of those triangles. And so because we have 1, 2, 3 sides that are congruent to 1, 2, 3 sides, we can say that triangle ADC is congruent to triangle. Now here's where it's important that the order matters. A is where I went first to D. Notice I have a 1 tick mark here, and then D to C has 2 tick marks. So I have to follow that same pattern when writing the other congruency statement. So if I start from pink to purple, I need to do the same thing for the other triangle. So pink to purple would mean that it's CBA. And we say that these two triangles are congruent by side, side, side. That's the method that we are using to prove this. And so in example 2, same thing here applies. The first side that we have is side CE, which is congruent to ED because they have 1 tick mark. So CE is congruent to DE. Then I can see that these two sides are marked with 2 tick marks. So we have CF is congruent to DF. And then once again, this third side here is shared among the 2 triangles, which would be the reflexive property, which states that EF is congruent to itself, which is EF. And so because of the fact that we have 2 triangles that are congruent based off of side, 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 we can say triangle CEF is congruent. And once again, the order matters. I went CEF, so I went from pink to orange. I need to do that same thing here. So this one's going to be triangle DEF because the order has to match when you're writing your congruency statements. I cannot say DFE because that's not the same. By side, 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 which is what we've proven right here. Okay. Now, there is another type called side angle side. This one says that if 2 sides and the included angle of one triangle is congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So this is what it is saying. Okay, before I get into writing it out here, I want us to look at the picture. If you notice, this side is congruent to this side. This side is congruent to this side. Now, this angle right here is congruent to this angle right here because of that 1 tick mark, or I guess you can say the little arch in each of them, okay? And so what this side angle side is saying is that if 2 sides and the included angle, and what the included angle means is that the angle between the sides. That's the key thing here, is the angle between the sides, okay, is what we consider an included angle. So this is a side, this is an angle, and notice it is between, and then this is a side as well. So you have side, angle, side, which is what you would call this method. And that applies here too, side, angle, side. So to write this out, we would say if side AB is congruent to side DE, those are my pink ones. And then next we have to state our angle. So angle B is congruent to angle E, which are my green ones, and then my purple sides. So side BC is congruent to EF. Because these side angle sides are congruent, then triangle ABC is congruent to triangle DEF. Because I went pink angle side, pink angle side. Okay? So those have to be the order that those are written. So let's practice this. We're going to state whether the triangles can be proven congruent if possible by side angle side. So in this example here, I see that I have this side is congruent to this side because they are both marked with one tick mark. So I can say that side QY is congruent to CK. Then I can see that this angle is congruent to this angle because they both have one arch on those angles. And so for my angles, I say angle Y is congruent to angle K. Then my other side would be here. And so I would say side YT is congruent to KP. Now, I also need to make sure I check, is the angle between the sides? Well, if you notice, side, angle, side, side, angle, side. So I have side, angle, side. I can say that, yes, the angle is between. And so because of that, I can confirm triangle QYT is congruent to triangle. All right, well, here's where I have to make sure the order's correct. I went Q to Y, which is my pink. Then I went Y to T, which is my purple. I have to do that same process here. So I'm going to start with C to K, which is my pink, and then K to P, which is my purple. So it should be CKP by side angle side. Now in example 4, okay, so I can see that these two sides are congruent. These two sides are congruent. And then notice that these two angles are congruent. Okay. However, what do you notice about these angles? Well, technically, are they between the two sides? No. In this case, because the angle is not between the two sides, okay? So if you notice, angle is not between the two sides. So these triangles are not congruent. And that would be our answer because it has to be side angle side. And in this case, we have S, S, and then A, which SSA is not allowed. Okay, it is not a correct form for congruency of a triangle. And it has to be side angle side, meaning it has to be between. And in this case, side angle is not a proper form. So therefore, these triangles are not congruent. All right, last one here. We have an example 5. We have these two sides are congruent. We can see that these two sides are congruent, but if you notice, there is no angle marked. However, using prior knowledge about angle relationships, technically, these two angles right here are what we consider to be vertical angles because we have two intersecting lines, and so these two angles are going to be congruent. So technically, we have a side, an angle, and then a side. So this technically applies. So we have the first side is BC is congruent to CD, okay, because those both marked with one tick mark. My angle, well, compared to example 3, angle Y and angle K were isolated and by themselves, so we were able to use one letter. However, this C here is technically included in both of these triangles, so we're not able to use just one letter. We have to use 3. So I can say that this, for this triangle, this angle right here would be angle BCA. Okay? And then this angle would be angle DCE. Okay, so then my last sides are AC, which is this one right here, is congruent to EC, which is this one right here. So because we know that the angle is between the two sides, I can say that this triangle's ACB is congruent to triangle. I have to do it in the same order. I went from purple to the angle to the pink. So ECD by side angle side. We are going to be using these two methods of side, 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 and side angle side to help us prove if triangles are congruent in the next section.